Imagine that you are a customer of an online store making various purchases regularly. The store owner occasionally offers discounts to his clients. You don't know when a discount will appear, but you have the opportunity to subscribe to a newsletter to get info about when a discount is available. You don't need to take any additional steps, just wait for an email from the store owner. The described scenario is a perfect illustration of the observer pattern, one of the most frequently used design patterns in programming. Its core idea is maintaining a list of observers interested in a particular event and notifying them when that event occurs. In our example, the observers are the store's customers. The event is the occurrence of a discount, and the store owner is the so-called observable who notifies the observers about the event. Let's take a look at another example of the observer pattern in action. YouTube subscriptions. Think about how YouTube operates. When you subscribe to a channel, you become an observer of that channel. The channel in this case is the observable object. Whenever the channel owner uploads a new video or posts an update, all the subscribers, observers, are notified. This is an instance of the observer pattern. The channel doesn't need to know how many subscribers it has or who they are. It just sends out a notification when there's new content, and all the subscribers are automatically informed. The observer design pattern consists of the following main elements. Observer interface. This is an interface that defines the methods required for observers. These methods are used to update the observers. Concrete observers. These are classes that implement the observer interface. Each concrete observer that is registered with the subject will receive notifications. Subject interface or class. This is a class or interface that maintains a list of observers. The subject notifies the observers on the list when there's a change in state. It provides methods for adding, removing, and notifying observers. Concrete subject. This is a specific class that implements the subject interface or inherits from the subject class. It's the class whose state is being observed. When the state of the subject changes, the observers are notified. The interaction between these elements is such that the subject maintains a list of observers and notifies them when there's a change in state. Observers can be added and removed from the subject's list of observers. When the subject notifies the observers of a change in state, it does so by calling a method defined in the observer interface on each of the observers. Now, let's take a look at a real-life example. For this, I have prepared a simple Maven-based project called Observer Pattern Demo. As you can see on the left side of the IDE, I have created multiple files that represent the elements mentioned in the previous section. In the main method, I'm creating an instance of a YouTube channel. The next thing is the creation of 2 users who subscribe to the channel. Finally, when the channel owner uploads a new video, both subscribers receive a notification that there's new content to watch. You can clone the whole project from my GitHub account. The link is in the description. The observer pattern solves several problems related to communication and dependencies between objects. Coupling. Without the observer pattern, an object would have to communicate directly with every other object that wished to be informed about a state change. This leads to strong coupling between classes, which makes maintaining and extending the code difficult. The observer pattern allows reducing coupling because the subject and observers are linked only through the observer interface. Dynamic responses to changes. In many systems, various objects need to react to changes in another object. The observer pattern allows for dynamic responses to these changes, without the need to check the state of the observed object at every cycle of the program. Open to extensions. It's possible to add new observers without modifying existing observed classes. This means that the code is more open to extensions. This is one of the main assumptions of the solid principle, open-closed. Abstraction. With this pattern, the implementation details of observers are hidden from the observed object. The observed object only knows the observer interface. This allows for greater abstraction and easier management of code. Flexibility. The observer pattern allows for dynamic addition, removal, and modification of observers during the program's operation, providing significant flexibility and managing dependencies between objects. Whether it's receiving notifications about discounts from an online store, being notified about new videos from a subscribed YouTube channel, or even more complex scenarios in large-scale software systems, the observer pattern provides a solution for maintaining a one-to-many dependency. in a way that promotes loose coupling, open extension, and dynamic responses to state changes. In essence, the observer pattern is essential when designing systems where the state change of one object needs to be effectively communicated and reacted upon by multiple other objects. Thank you for watching. If you found this video helpful, please hit the like button. It really supports my channel. And don't forget to subscribe for more content. Click on the bell icon to get notified about my latest videos. Thanks for your support and see you in the next video.